Hi, today we're going to be working with 5.5 part 1, and these are going to be using the formulas from your formula sheet that we haven't used yet. Now they're also in the box here, and these are called multiple angle and product to sum formulas. Today we're just going to be doing the multiple angle formulas. So what that means is you might see a 2 in front of your x, or a 2 in front of your x here with tangent, and then you could also be with cosine. So these are called double angle formulas. And all you're going to do is if you see sine of 2x, it's the same thing as 2 sine of x cosine of x. So you use these when you don't know anything about the angle, but you might know the ratio of your sides. So let's practice with the first one here. And you're probably going to also want your unit circle out today. I'm going to use my little one that we created. So let's start with number 1. We have 2 cosine plus sine of 2x equals 0. So right here, I see that I have a sine of 2x. I'm going to use the double angle formula from my formula sheet or right here from our notes. So that's 2 sine of x cosine of x. Now I can solve just like we have been when we learned how to solve trig equations. So this one, I can factor out a cosine, and I can also factor out a 2, so 2 cosine of x. That leaves me with 1 plus sine of x. And now to continue solving, I'm going to set both of my parts equal to 0 and solve. So over here, if I divide by 2, I get cosine equals 0. And over here, I get sine equals -1. So now I'm going to get my unit circle out. So first, let's see where cosine equals 0. So cosine is the x, and cosine equals 0 at pi over 2 and at 3 pi over 2. I also want to know where sine, which is the y, is -1. So sine is -1 at 3 pi over 2. Well, I already wrote that down, so I don't have to worry about that. So I'll just leave it. But there's no increment here, so I'm going to add a 2 pi n to both of these. So that will represent all the answers that work. Now, just like from before, you want to make sure you check your answers. So you can do that by plugging in pi over 2 for x and 3 pi over 2 for x and see if that works. Okay, so let's look at number 2. Number 2, we're going to analyze a graph. So number 2, I'm going to go right to my calculator, and I am going to plug that function in. So it's 4 cosine squared. Now when I plug this in, I want to plug it in by squaring the trig function. And I'll write that down on the paper here too in a minute. -2. So we're typing this in as 4 cosine of x squared -2. Okay, I'm going to hit graph. And I was already in trig mode from the last time I used my calculator, so make sure you do zoom trig. Now, they just want the interval from 0 to 2 pi, so we can also go to our window and change our x min to 0 and our x max to 2 pi. And then it'll show us exactly the range of values that we're looking at. So if we had to analyze our graph, some things I notice about this graph is I have 3 maxes, and they're both at 2, right? Because normally our amplitude would be 4, but this graph got shifted down 2. That's the 4 and the -2 in the function. So my amplitude is 2, so I have maxes at 2, and then my mins occur at -2. If I want to find exactly where they take place, you can use your second trace. You can find your zeros, you can find your minimums, you can find your maximums. So let's practice finding a 0 on this one. Let's find the first 0, which would be right here. So this graph has 1, 2, 3, 4 zeros that occur between 0 and 2 pi, so 4 answers. So let's just find one of those answers. So I'm going to go to second trace, 0, and left, right, take a guess. So I'm going to go to the left of where it crosses the x-axis, go to the right, and then last I'm going to take a guess. So my first 0 is at 0.785. And you can go through and you can find the other 3 zeros the same exact way. Okay, so just reviewing that a little bit, right? This is our amplitude, the number out in front. But this -2 shifts the graph down 2. So instead of going all the way up to 4, it now goes to 2. But it still has a difference of 4. It's going from -2 to +2. So I'm also going to label this. We have a 0 at x equals 0.785. But total in that region, there were 4 zeros. Okay, let's go to number 3 next. So number 3 says, use the following to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So first I'm going to get my formulas that I need. So I'm going to copy from the top of my notes there what sine of 2 theta is. Sine of 2 theta is equal to 2 sine of theta, cosine of theta. So in order to solve this, I need sine and cosine. But I only know cosine. They also give us a range of values, 3 pi over 2 to 2 pi, which means I'm in the 4th quadrant. So if I know cosine, I'm going to sketch a little diagram here, draw a triangle in the 4th quadrant, and I know 2 sides of that triangle. I know adjacent, and I know the hypotenuse. So if I want to figure out the 3rd side, I can use the Pythagorean theorem. So a squared plus b squared equals 13 squared. That gives me 144. So my missing side is 12, and it's going to be a -12, right? Because you have to go to the right and then down to get to the 4th quadrant. So that means I can now know what sine is. Sine of theta is opposite over hypotenuse. So now I can actually solve this. 2 sine of theta, cosine of theta. So if I multiply those together, that gives me -120 over 169. Now what this is saying is that here we have a triangle with an angle, and we know all 3 sides. But the double angle, so if I double theta and I wanted to find the ratio of sine, the ratio would be -120 over 169. Okay, let's go to cosine of 2 theta. So my formula for cosine, and there's 3 of them. So if you look up at the top, there's 3. I can pick any one of these to use, whatever one you think is easiest. You have cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. You can use whatever one. So I'm going to pick the second one. I'm going to use the 2 cosine squared minus 1. And I know what cosine is. It's 5 over 13. So I'm going to use my calculator to plug that in. 2 times 25 over 169 minus 1. And you can do math enter to get a fraction. -119 over 169. Okay, last part, tangent of 2 theta. So that one only has one formula at the top here. It is 2 tangent of u over 1 minus tangent squared. So let me write that down. 2 tangent of theta over 1 minus tangent squared. So for this one, I need tangent. So I'm going to go back to my right triangle here. I'm going to make a list. Tangent would be opposite over adjacent, so 5. Okay, so 2 times negative 12 over 5 divided by 1 minus negative 12 over 5 squared. So I would just type that in my calculator. You can use your fraction bar to help you so that you don't make a mistake with parentheses. So if you want to pause it and figure that out, the answer is 120 over 119. Okay, so we have a couple more formulas we're going to go over in this lesson. These are called power reducing formulas. So these formulas you can use to find squares. So number 5 says, rewrite sine to the 4th power as a sum of first powers of the cosines of multiple angles. Now this can sound a little confusing, but what they basically want us to do is simplify this so that we don't have any squares. We just want regular functions. So sine to the 4th would be like having 2 of these, right? 2 squareds. So I can write this as sine squared, and I can use that formula, 1 minus cosine 2x over 2 to the 2nd power. And then after that, we can multiply this, right? We can FOIL this. So I can rewrite the top twice. The bottom would just be 4. But if I FOIL the top, that gives me 1. Outer would be negative cosine of 2x. Inner would be negative 2 cosine of 2x. So that's 2 of them. So minus 2 cosine of 2x. And last would be plus cosine squared of 2x over 4. Now we got a little problem here because the question said they want first powers of cosines, which means I can't have any squares, and I got a square right here. So last thing I'm going to do is just fix this one more time. 1 minus 2 cosine of 2x, and then plus cosine squared from my formula sheet up here is 1 plus cosine of 2x over 2, all divided by 4. And then we can't have a fraction and a fraction. We talked about how that's not allowed. So I can multiply everything by 2. That would give me 2 minus 4 cosine of 2x plus 1 plus cosine of 2x over 4. Oop, I forgot to multiply by 4 by 2 also. So that's 8. And lastly, we can combine like terms, right? So I have cosine of 2x here twice, and I have a 2 and a 1 I can combine together. So that is 3 minus 3 cosine of 2x divided by 8. Okay, so let's try the last one. I think I misnumbered these though, so this should probably be number 5, but it's number 6. So let's do this the same way. Rewrite cosine to the 6th power in terms of the first power of cosine. So I can write cosine to the 6th as cosine squared to the 3rd power. That's the same thing. And I have a formula for cosine squared. So I've got 3 of these to write. 1 plus cosine of 2x over 2. 1 plus cosine of 2x over 2. 1 plus cosine of 2x over 2. So for now, I'm going to have you guys not simplify these because most of the time you're going to be given values of x to solve. Sometimes you'll see these pretty rare in like proofs and things like that. So for now, we're just going to practice using them if we have to, but I'm not going to really concentrate on the whole simplifying part. So if I have you use these formulas, it's just going to be evaluating. So plugging just a number in for X and solving. So we're going to finish this one right here because otherwise we got to FOIL all these together and do a whole lot of distributing, but we're not going to do that because again, we're concentrating more on using the formulas. So I might say if X is equal to pi, find the sine squared of pi using the power reducing formula. So you would plug pi in over here and then you could solve. Okay, so that concludes our lesson, and basically we're going to be spending some time in the next lessons and just using the formulas, how they work, when you use them, what to recognize, and you might see some proofs that use these formulas as well. So that formula sheet that you guys should have printed, or maybe you have it saved on your computer, make sure you use that as a reference as we go through these because we're going to basically, for the next couple weeks, learn how to apply all of those formulas. So by the end of this unit, you'll be able to use every formula on that formula sheet.